Okay, so I think let's look it up. I'm just showing a couple of examples very briefly. So this is something else. It's Brandon Dave's. The project was called Singular Redux from 2004. So he used processing, which at that point was just emerging. And he took few films such as Tekstura and Vertigo and reduced and extracted 1 frame per second. Reduced every frame to 6 by 6, 6 by 6 pixels, and made these visualizations, which in fact very much inspired what we're doing, inspired projects we're doing in my lab. You kind of see this cinematography kind of color, and also, of course, since the cinematography in some ways reflects or follows or parallels the narrative, certain patterns, right, day and night in these films. And then this is was also a solid sequence of those projects from 2005. Lee Byron, who sometimes collaborates with Martin Gutenberg, so it's also from 2006. Maybe he took his listening history, Master FM, and visualized his listening history as in this form, and this was also a kind of visualization technique which can be published in paper. So one thing I just want to say before we kind of actually start maybe discussing it more theoretically, and it's something I just recognized like literally a few weeks ago. So what's interesting is, if you go to this website, right, there are thousands, I think this one has like 4,000 projects, and of course there are more because now lots of students are doing it around the world. And I started wondering, right, so why there's like 3-4 people who really became famous in this field. And when I say famous, I'm not talking about influence in general, but it's also like this area of artistic or cultural visualization. What I recognize is that, okay, they're very smart and they have good ideas and good aesthetics. But what's also interesting, in fact, what actually separates Martin Gutenberg or Lee Byron is that we actually invented genuinely new visualization techniques, which in fact we described in papers we published in infamous journals. And in fact, if you go to Martin Gutenberg's website, every year he writes a paper which is awarded the best paper award in these infamous conferences, which have thousands and thousands of capital scientists. And I think this is why this project actually stands out, right? So you can have a brilliant idea and use a bar chart, and probably people will say, okay, very nice, and move on. So in fact, it turns out that one of the things which I think separates these few people from the rest of us, we're actually able to invent genuinely new visualization techniques, which is very hard to do, because we'll talk a little bit about the history of this field, and it turns out that most of these techniques have already been invented in the first decades of the 19th century. And then I think the second stage of invention really starts happening in the 70s, because now people can use computers which can manipulate more data and can make more complex graphs. So in the 70s, 80s, 90s, well, people maybe in computer science invent 4 or 5 new techniques, but it's actually kind of hard, right? It's hard. So the fact that you have these people who are actually participating in the kind of, well, I wouldn't say art world, but in a kind of culture world, and able to invent new techniques because they have some computer science background, it's actually kind of quite exceptional. Okay, so now let me just do one more thing, because I don't want both people who know about this already and people who don't know. Sometimes we make this mistake that we think of visualization as only something which you encounter, right, on projects such as visual complexity, on websites such as visual complexity with aesthetics. You think of it something very colorful, very beautiful, some network. But of course, every day, every single person who goes out there and starts doing PowerPoint, and supposedly there were 70 million PowerPoint presentations being done in America every day, and starts showing bar charts. It's also visualization, right? So in this seminar, I'm going to talk about information visualization in this more extended frame, and I want you to think, you should be really thinking about history flow as exception and kind of bar charts and pie charts as the norm. So to that extent, the principle is exactly the same, right? So I think before we do the discussion, let's make a little bar chart so that you have like a more normal visualization in front of us, so we're not necessarily thinking that it's all kind of complex and with beautiful colors, right? So let me see this here. Okay. And of course, as I do it, I will slowly also introduce the ideas of kind of culture visualizations, which are, let's see if we can get something about the internet here in just a moment. Yes. Well, it's interesting. It's like, what if one day we have, right, the ecological crisis gets to the point where it becomes really kind of difficult to use computers, so can we actually survive to a similar about internet and just experiment. I think I can do it, but without the jet lag. Okay, just give me 1 second. Right. So, one of the things we're working on is visualizing patterns across things like comics. So this is a particular web comic. So web comics, right, are recently new phenomena where people are publishing comics online. So that's a particular comic called Freak Angels from US. And so we downloaded, we downloaded all the pages, so every week. And this web comics can follow the format of traditional comics, right? But traditionally you would go by a book, and the book will have chapters from a number of comics, right? So you have a title of a series, which may be going for many years. And some of the most popular titles in Japan, such as One Piece, Bleach, some of them started like 97, so we keep going. So we'll look at this later. So one of the titles we're looking at has like 15,000 pages, which have been created over the course of 10 years. So this is just the pages which were uploaded on the website over the course of a year and a half. So and it has this standard format where every week we add one chapter, and one chapter will be just 6 pages, right? So the 6 pages would be basically 1, 2, 3, 4, 5, 6 would be just one chapter. I should make it bigger, right? Just a second. Oh, maybe I don't have it. I don't have it bigger because this is like I reduce it down because I wanted to visualize them. Okay, but so this is the significability, right? So 1, 2, 3, 4, 6, and then next week will be 1, 2, 3, 4, 6, etc. So one of the things we do, and we'll talk about this later, we use a software to automatically extract various visual properties, such as color, texture, saturation, and then we can plot them all the time. Okay, so we're going to make, so this is already not normal, but the process itself is kind of unusual, but we're going to use very standard techniques, like basically bar charts and line graphs to do it, right? Let me see, we'll open something here. Okay, so that is good. Okay, so let me make it bigger. Okay, so this is the typical data which you can visualize, which is essentially a spreadsheet where each object, let's say each object or each point, I'm going to call the point, although we don't have these points to visualize it, so each object in this case is going to be a row, and then each column is going to contain some property, some aspect, some feature, right, of these objects. In this case, our objects are these web comic pages, right? So this is page number 1, page number 2, page number 3, right? 1, 2, 3, 4, etc. It kind of goes on. So how many pages is that? So this is about, let's see. Sorry guys. Okay, so this is only 342 pages. Yeah, well I guess 6 pages a week. This is something like that. 650 to, it's for something to get actually. Right? Maybe it's 1 year. You can calculate that. 6 pages a week multiplied by 52 weeks. It's a couple of years actually. Anyway, so this is the data. So the label in this case identifies the object. So the label is the name of a file. And then this is some measurements, right? So mean is simply the average of brightness, and standard deviation is the standard deviation of brightness, etc. Okay, and we can basically see how the average brightness of a page varies, right, over the life of this comic book. And we can simply open a blue cell, and here we have a bunch of standard techniques. Now, I spent lots of time kind of going to all the Wikipedia pages related to visualization, and I came to a conclusion that in fact, not only the definition of visualization is not agreed upon, but even some, let's say, elements in visualization culture don't have stable names. So sometimes, some people would call this visualization techniques. Sometimes people would call this statistical graphs. Some people refer this as charting techniques, right? But ultimately, because I want to emphasize that this is all part of the same kind of family, and we'll talk about what is this commonality is. I mean, I'm going to call this visualization techniques. So you probably don't think of bar chart as visualization, but it is, right? So now we can go use something very standard, such as we can visualize each of this number as a column, or we can use, for example, a line. Okay, so we can do that. So we can select a line, and here we go, right? Okay. And what we find is that, even though this comic has been kind of published in parts, 6 pages a week, there is a nice continuity. So the brightness kind of goes up, and the brightness goes down, and goes up. And this is, of course, if you look at the comic, this is the part which takes place during the day, and this is the place which takes place during the night. So it's not necessarily. But what's interesting is that if you smooth it out, it's interesting that there's this kind of trend, right? And the trend, and of course the trend has to do with narrative, but it's interesting that even though there's little variations, right, from panel to panel, overall, it's a very kind of simple pattern, right? And we can do it by creating, very simple technique, introducing a trend line, which is, in this case would be something which is also used in finance. So I'm going to teach you how to use financial techniques for cultural criticism, which is kind of fun. Not because it works of value, not because of animated capitalism and Lucas, not because we can just use the techniques themselves, right? So we can have a trend line which would basically average, right? Which is the average, which would average the points, and as we average more and more, right, the pattern becomes more and more visible. So here we go, right? So what this is simply, in this case, taking every 3 points and creating averaging as a line afterwards, right? So here it is, we created a very simple visualization itself. Right, so now let's look at our pages and actually see if it makes sense. Again, I mean, I'm just simply showing you, reminding you about Excel, so I'm not trying to make something very meaningful right now. In fact, what we can do is that, let's say we can actually load these pages in our program, we can look at the movie, so we can actually get the feeling if, for what is really happening in terms of brightness. So let's see, we can actually use it for as well. We can use QuickTime, but then put it in our program, which I'll show you in more detail tomorrow. Or maybe today, if we don't get access to the internet, called Metamediji. So this is one of the common software we use. It's kind of Photoshop of science. You maybe haven't heard about it, but it's a common tool used in all of life science, astronomy, biology, medical research, to visualize scientific data, in particular medical data. So right now we're going to use it as a QuickTime, kind of in a way to open all these images in sequence. Let's see if it's going to work. So we can take a look. Just a moment. So yes. Just trying to. Normally you kind of work with high resolution, so we switch to projected so I can name. Oh, okay, that's fine. Let's see if it works. Yeah. Okay. Okay, so here we go, right? So we basically loaded all the pages, right, in the kind of movie. So here it is, right? Okay. And here you can see this kind of drop in brightness, right? So here's the graph, right? I mean, this is like very primitive example, but this is how I actually started a year and a half ago, and then, of course, things make it much more interesting. And so those are triggers, right? So we can basically play it as a kind of movie if you want, of course. Okay, that's fine. So you can say, okay, let's go forward. So here we go, right? Oh, sorry, it doesn't want to start. Why does it want to start? That's interesting. Okay. So we can see here's our phenomena, here's our artifact, right? Here's our slice of a world of culture, part of one comic book, and here's a visualization which shows us the pattern, in this case the temporal pattern, right, in a particular dimension, particular aspect of this phenomenon. Right? So to me this is, I think, a very good example of visualization in general, and of course, most of us who teach, right, sometimes we have to use Excel to grade the curve, right, so we know all about it, but maybe you're not so familiar with applying these techniques to cultural artifacts. Okay, so this is fine, let's stop it. So we have something like this, right, which is very, very kind of simple, but it's hard to find today PowerPoint in business which wouldn't have it, or in science. And of course we have something much more elaborate. So let's try to actually ask some questions about what distribution is. And I'm going to start with a quote. So a few weeks ago I was in LA and I went to see the exhibition, which was the original art, the original photographs, and the drafts, the mock-ups of Robert Venturi, Stefan Isanor, and Dennis Brown, famous opus, Learning from Las Vegas, 1972. So it turns out that we took a trip. So basically, I think he was teaching Yale, and he took a trip to California, which I'm sure was as alienating for them as it is now. People move from New York to LA, and we published this book, right, which became one of the most important books in culture and criticism, right, in the second part of the 20th century. And there was a quote. So this is a quote from 1972. The pretty photographs we and our tourists made in Las Vegas are not enough. How do you distort this? How do you distort this to draw a meaning for a designer? How do you differentiate on a plane between form, that is to be specifically built, shown, and that which is, within constraints, allowed to happen? How do you represent the strip as perceived by Mr. A rather than as a piece of geometry? As relevant today as it was then, right? How do you show quality of life or qualities of form in a plan at 1 inch to 100 feet? How do you show fluxes and flows with seasonal variations or change with time? Well, I'm sure what he meant was much more than that, but let me suggest that perhaps using visualization combined with measurement, we can actually start representing some of this data and some of these patterns that we're dreaming about. But of course, very general questions of how to present the subjective experience, for example, architecture or we should call Las Vegas urban environment, I don't know, whatever it is, space, as opposed to objective data. I think this question itself remains as valid, right? Because if you go to visual complexity in the InfoAesthetics website, you find that a great majority of visualizations do not represent human experiences. They represent the experience of data. It's portraits of data, it's not portraits of us interacting with data. So to that extent, I think what is also really special, and that's of course the difference between Stephanie project, right, which is, I would say, represents the data, right, the structure, particular structure of a novel, versus, I would say, a more rare project by Martin Württemberg, which actually represents the kind of human experience, right, of creating this data. Now, I actually haven't seen any visualization yet, so this would be a great project for us. I know we can do it like in a day, but can we actually visualize somebody's reading experience, right? And not just abstractly reading experience, but the actual reading experience, right? Based on some kind of data we're going to collect, I don't know. How to do it, I mean, you can basically track eye movements today, which is pretty easy, or you can do MRI, right? So to that extent, I think the challenge which Venturi and Brown have put to us in 72 partly is being solved because we can now use these visualization techniques, and we'll look at more ways in which we can visualize the kind of visual aspects of the world. But I think it also remains, because one of the critiques we can put to the whole culture for this, that where is the human subject, right? So we can also say, to conclude this little introduction section, we can also say that the data has become yet another new subject of contemporary art. And of course, contemporary art introduced a number of new objects, new subjects, and it's kind of evacuated what used to be the main subject of art, which is the human being and his or her existence in the human society. Right? So we have modern art, which introduces abstraction, which we of course can relate to visualization quite soon. Right? When eventually we can say that the art itself, art world, the creation of art, art materials become subject of art, etc., institutional critique, etc., and now we have a new subject of data. So it doesn't mean that only movies are going to represent human beings. Right? Just put some more normal example of something which is not art. Let's see some normal. Okay, here we go, right? So that will be okay. So that's obviously a much more common way in which people encounter visualization. So this is again line graph, which everybody, each of you can get if you sign up for a pro paper account. It actually gives you kind of statistics, right? How many people accessing the website, and of course, if you ever use tools like Google Analytics, you can do the same. Okay, guys. So normally I don't do it, but what happens, of course, if you just talk, things progress much more slowly because I really want to cover particular things. I'm actually going to do something which is, again, I never do, but I will try to do it a little bit. And of course, I will interrupt myself all the time, which is I'm going to actually, the next section I'm actually going to read you from a draft of this article I've been working on, which seems like it's in a way to become a book about visualization. And the article will be called, What is Visualization? So now we have some examples, right? And we saw some patterns which indicate that it's becoming more and more popular. In fact, another kind of sign of this is that two of the most prominent visualization designers, which is Benjamin Fry, Ben Fry, and Martin Gutenberg, the author of History Flow and many other projects, this spring have left the companies we've been working for to start their own design firms focusing on visualization. And in the interview about why did he do it, which was literally a few weeks ago, Martin Gutenberg said, well, I believe visualization is becoming new mass medium of our society, so I want to be in it. So what is visualization? Well, despite the growing popularity of InfoVis, it's not so easy to come up with a definition which should work for all kinds of InfoVis projects we created today. And at the same time, we've clearly separated from other related fields, such as scientific visualization and information design. So if you go to Wikipedia and start looking at the web pages for these different fields, they all can refer to each other, so it's a kind of circular definition. Okay, so let's start with some very provisional definition, which we can modify later, just to put something in the table. So let's define visualization as a kind of mapping from other types of representation, non-visual representations, to a visual representation, right? So it's a mapping from other types of representation to a visual one. Now this mapping, of course, can be static, animated, to interactive. And of course, in the later case, we also need to include the interactive tools, which allow us to use, which we can use to interact and modify visual representation. So I guess we can say that this will be a static visualization, produced by Flickr. But of course, we can go back and, for example, we can do it instead of, and obviously we can say, okay, instead of looking at all this data, let's go and only look at a part of the data, so we can kind of look at the patterns more closely. For example, over like first year. So first year will be about well, it's actually only 1 year. Let's say like at 1 month, so it's going to be 24 pages, right? So we can just change it. And now we see the graph with just part of the data, right? So it will be one example of simplification we can do. And of course, now what you can do is, of course, instead of looking at this variable, you can basically use the same visualization, which you already established, and simply switch to a different variable, which is, you can do this. So instead of using column C, you can use column D. So now our visualization, the structure is the same, but the data which has been fed in structure is different. And if you go back and switch to defaulting, which is, you can go all the way to 343 here. Okay, so now we go to see something else, right? This is incidentally just standard deviation of brightness values. Okay. Now, of course, we can also use different concepts besides the presentation, and whatever concept we use is going to bring its own meaning. For example, you're back, because I wanted to be theoretical because I know you're interested in the subjects. For example, if you believe the brain uses a number of distinct representational and cognitive modalities, we can define info-vis as a kind of mapping from our cognitive modalities to visual modality. Now, again, this is a very kind of provisional simplistic definition, but it's something to start with, so we can modify it later. And it doesn't cover all aspects of info-vis. So it's not talking about the distinction between static, dynamic, animated, and interactive visualization. And of course, it's interactive visualization, which is really the most important topic today, which is partly responsible for its growing popularity. There are lots of other definitions. You can also think of visualization as a kind of new tool of thinking, not just new technology for cognition. But since I'm interested in visualization in the context of history and visual culture, I'm going to focus on its, let's say, the fact that it's a visual representation. Now, interactive graphic interfaces in general, and interactive visualization in particular, bring all kinds of new visualization techniques for manipulating data elements. For example, think about your operating system, right? Think about your operating system. This. It's a visualization. You never thought about it, but the graphical user interfaces, right, which become popular after 1984, after the introduction of Metamediji computer, it's a visualization. It's a visualization of data on your hard drive in your programs. Right? And one of the basic ability, one of the basic function, which you can do with interactive visualization, which you couldn't in the 19th century, 20th century with bars and graphs, is you can change the way in which the data points are displayed, right? So, for example, in the case of my file system, right, I can look at my, what is here, right? There's nothing there, just open something. I can look at my, I can look at my files, as a list, right? Instead of icons or as folders. Well, graphical user interface is a form of visualization, and this is a particular very general, right, interactive visualization technique. So in the same way, I can just do it with my files, right? I can go back to the Excel graph, and for example, instead of representing this as a line, I can basically go back and I can represent the same data, right, as a column. So I think if I was using the Apple visualization program, I was actually be able to switch it right here. In this case, I think I have to go and actually make a new one. But normally you'd be able just to switch, and the line would become a bar graph, right? Okay. And of course, I can also do other things. I can go and make this line, right? Thicker and change its color and so on and so forth, right? Oops. Didn't do anything actually. Okay. Okay, maybe you did. Let's go crazy. Okay, she didn't do anything. That's interesting, right? Okay, maybe it's because maybe it's this line. Okay, maybe it's this line. So there's so many controls. Scan not what I wanted, and of course you can take the same data and you can also go and basically make it the bar chart, right? So what I want you to realize is that structurally, right, what I just did is basically exactly the same thing, right, as when you do this, right? So, and this is, you can say that the ability to map, let's say, the same data into different kind of different visual structures and different similarity code. It's one of the basic abilities of basic functions of interactive computing. So the extent of visualization, you can either say it's all visualization, or you can say visualization is simply, right, kind of stands on the shoulders of a kind of giant, which is interactive computing, right? Interactive interface. So it depends on how you see it. Okay. Now, regardless of whether you're looking at visualization, fixed on paper, or dynamic arrangements of graphic elements on your computer screen, which are generated using interactive software, right, in which you can change at any point, at any moment. Right? In both cases, the image you are working with is a result of mapping, right? So I like this word mapping because it's kind of very general, and it talks about the process of how we get from these numbers to a new representation, which is a picture. So what I want to talk about next, right, in our lunch, is what is special about images such mapping produces. Right? So, many of you read various works in history of visual culture, Gombrich, Svetlana Alpers, people discussed, for example, there has been lots of discussions in art history, already in the early 20th century, with works like Panofsky, Perspective in Symbolic Form, about different types of representations used by human beings, at least in Western tradition, about perspective, lots of discussions about photography and film and our lens-based representation, but there hasn't really been much discussion about quantitative display of visual information. In fact, now there are books which are coming about it, but still most of the books are kind of how-to books. And in fact, there was only one book published in the whole 20th century about quantitative graphics, which was a book published in 1968, which is called Theology of Graphics. Right? And the book is kind of interesting, but lots of things happened from 1968. Right? So when I was at this conference about visualization in humanities, just a second, visualization in humanities at MIT, where MIT Press had a table, and we kind of wrote together various books about infobis. It was interesting to see how just in the last few years there's now like a dozen books, and some I didn't even see. So I don't know how much of theoretical discussion is inside them, but this is really very kind of new phenomenon. So let me see if I can just leave it out just a second. Okay, here we go. So let me see. Okay, so here it is. So I just kind of went around and just took the books from the table. So this was literally the table. So if you have some books, so I have beautiful data, visual thinking design, now you see it, visualizing data. But most of the books are, either like this how-to book, how to do it, or which is this one, or it's like a kind of table portfolio book. So here's some early book, information design. And here's, of course, the classics, which Tafte, which really brought this to the surface, right? So here's Tafte books. So it's kind of interesting. And of course, at this point, you can put all these books on a table about that size, right? So that's why it's really exciting to be talking about this field, because it's very fresh. So you have this again, these big coffee table books, such as Data Flow. And this is something coming up, Atlas of Science, Visualizing What We Know, it's coming up. Another book about kind of visualization in science. This is a coffee table book. And then, sorry, I just kind of really got excited, taking pictures. Now this is a book about a particular project by Jonathan Harris and Paul Pine. So he kind of made a whole book about this visualization project, which is interesting. And this is one just came out, the cultural diagrams. It actually looks like the most theoretical of it, right? But that's basically you can put it forward. You can just put it, cover up on this table and you'll be done, right? So, good. So it's nice because we can really ask this question. We don't have to call 200 people. So what is special, right, about these images which emerge, let's say, which are started to be created, in the beginning of the 19th century? So it's about the practice of information visualization is actually older than photography, but not much older. Right? Well, what is it? What's special about this technique? Well, so first of all, let's see if we can actually differentiate between different kinds of visualization cultures, visualization practices. So I'm going to go, sorry, I think I still have to align my slides, because somebody just put down it's Europe, so maybe we have to wait, we have to have coffee first, right, obviously. So I'm sorry guys, it's a little bit, just like, yeah, okay, so for some writers, right, some writers make a differentiate between information visualization and scientific visualization, right? So the typical example of scientific visualization is the typical example of information visualization. Right? And this is how, for example, Wikipedia does it. And the idea is that the scientific visualization, the data is always numerical, so the data is always numbers. Right? While supposedly information visualization focuses on non-numerical data, such as texts and networks of relations, right? So we can say that, right, this other examples I was showing you, supposedly would be classical example of infobase, because input data is not numbers, but input data is text. And in this case, it's, well, we have to think about what's exactly is the input, but we can say it's also not numbers. Right? Or for example, in this case, right? Well, I'm not visualizing, temperature over the last 100 years to figure out if global warming is happening or not, right? I'm just visualizing a recent history. So at first glance, that looks to be like a meaningful definition. But I'm not so sure. I'm not so sure. Why? Well, because if you actually start looking at every single information visualization project, realize that it actually uses numbers. Right? Why? Well, because most of these projects, again, they're images, where it's a relation between graphic elements, which represent information, which means you need to have some coordinates, right, to put these points somewhere on the surface. And coordinates, of course, numbers. So it means that even though what you're visualizing is something else, to create visualization, you have to convert the phenomena into numbers, right? So in this case, we can say that, and again, I'm not talking about the fact. I'm not talking about the fact that, for example, the Excel automatically, right, assigns a number to each object. I mean, it's kind of obvious, and this is not so interesting, right? But what I'm talking about is that, for example, in the case with bar graph, right? I mean, in order to determine the height of every bar, I need to have a number, right? So somehow I have to quantify my data, regardless of whether it is flight patterns, my music history, or authorship on Wikipedia, right? So that's why I'm not sure if the distinction is so meaningful. So for example, a typical network visualization may use both the data about the structure of the network, which nodes are connected, and also quantify data about the strength of these connections. So if I'm visualizing the connection between me and other people on Facebook, right, let's say each person may be represented as a point, and then I can, let's say, supposedly, right, if I have access to this data, I can extract like the number of messages I exchanged with every person over the last month, and this will be the number which can determine the size of a point, or let's say width of a line connecting the points, right? So if you look at the examples we have already discussed, you will see that in fact we all use some numbers. So for example, in the case of history flow, right, in case of history flow, well, so it shows how a given Wikipedia page grows over time as different authors contributed, right? So now you notice that some the contributions of different people, right? Sometimes it's just a very thin line. In this case, this person basically gets a very thick line. Well, why? Because Martin Gutenberg's program counts the number of words this person has put on the page, right? Okay. So width of the line changes over time, reflecting number of words contributed by each author. So again, I'm sorry I can't do it right now, but hopefully I'll be able to do it soon. No, it's not. Okay, that's not it. Just a second, just a minute. What we can do, when we get access to the internet, what I've done is that I said, let's actually look at what people actually produce, and let's see if we can separate these two practices visually. So what I've done is, I simply went to Google image search, and I put in scientific visualization, and when I put in information visualization, and you get very different sets of images. Okay. So when you put scientific visualization, what you're going to get, a majority, not only, but the majority of images are going to be something like this. Where kind of three-dimensional, where solid 3D shapes or volumes made from 3D points. So we can represent, for example, simulation of earthquake or something else, but it's kind of 3D. In development of scientific visualization, kind of coincides with advances in 3D computer graphics in the 1980s. And we feel kind of really gets underway in '88 when a few scientists make a proposal to NSF to start funding scientific visualization as a distinct field in computer science. And then if you search for InfoVis, you're basically going to get lots of things. Most of the images are going to be two-dimensional, and we use convective primitives such as points, lines, and maybe shapes. So the main difference turns out to be not in the kind of data we visualize, but in the kind of visualization techniques they favor. Okay. And again, you better for example online, but I think these examples are maybe not. Okay. So we can say what we do.
Because it's even a sentence of metric.
Well, yeah, but okay, well, no, but it's on, but the thing is,
Maybe it's not.
No, somebody has to come, so we'll probably see this person, right? So maybe we have to, I don't know, get some whiskey and lots of, I don't know, what you use in Switzerland. I mean, obviously have this chocolate here, right? So we could say the two fields are distinct on the level of visual techniques and technologies, as well as cultures where they come from. Okay. So scientific visualization develops in the 1980s along with the field of 3D computer graphics, which at the time required specialized graphics workstations, and the field of InfoVis develops in the 90s with the rise of popularity of 2D graphics, software, and adoption of designers. And of course, it really picks up in this decade because of first availability of data, made possible by the APIs of social media networks after 2005, and so there's lots of kind of easy, cheap data to combine. And also, of course, democratization of programming via processing in our high-level languages. Okay, so this has been, actually that's been kind of easy, right? It's actually easy. But now comes, let's say, a more, more difficult part. And let me again, luckily I have at least one example of everything I can possibly talk about on my hard drive.